This is lecture 5, example 3. We've been doing some programming problems, and this is going to be another programming problem here that's going to highlight bit masking. So our example problem is a notion of takes a register, which is x10, and it swaps the upper and lower bytes in that register. And so, the registers are 32 bits, and it swaps the upper 2 bytes with the lower 2 bytes. So that's worth drawing a picture of on this problem. Let's do that. So the subroutine itself is going to take the upper 2 bytes right here and move it down to the... It's going to take the lower 2 bytes and going to move it to the upper 2 bytes. It's also going to take these upper 2 bytes here and move it to the lower 2 bytes. So that's visually what we're going to do in this program. And so we can draw a flowchart. We're trying to be good programmers here. Let's say swap half-word. And we need to initialize stuff, like what I always do. Certainly in this problem has some special initializations, which are typically the masks, and some other stuff, you'll see that. And we'll do upper. So we have to do both upper and lower bytes in this thing. Upper 2 bytes. And there's that. And then once we get those all formatted properly, we're going to combine them. And then we're going to return. Okay, so once again, I got to initialize some stuff and do the actual swapping and then combine them. I'm going to be working with 2 different registers here, so let's do this. So we called this swap half. And I always like putting a init in there because it always needs an init. And so the thing I'm going to do in the init, I need to actually do 3 things. I'm going to make a working copy of x10. I typically have to do this in subroutines. So I'm going to move x10 into x11. So this instruction takes what's in x10, copies it into x11. So that's good. Now the other thing is I need 2 masks in this problem, and they are pretty large masks. They're larger than 12 bits, which means I got to put them in registers first. So I'm going to load some registers with mask values. Okay, as you can see, these mask values are, I'm going to use these things to mask the upper bits and the lower bits when I do this problem. And so let's do this. Let's give it a good label. Do low. Okay, here are the lower bits. So what I'm going to do here is I'm going to take that value in x10. It doesn't really matter if I use x10 or x11. I actually don't know what the solution uses. It's going to mask that thing and store that value somewhere. So we'll go ahead and do that. We'll say and x10 with x20. So what this is doing is ANDing the value in x20 with x10. So essentially what that's doing is clearing the lower bits on this thing. Okay, so once I've cleared the lower bits, the lower 16 bits, I have what the 2 bytes up top, what I'm interested in. So I'm going to shift right, logical, immediate, x10, and 16. So that's going to take the value in x10, shift it 16 times to the right, store the result in x10. Okay, that looks good. That's all I need to do for that. But I need to do the same thing with the upper 2 bytes. So let's do this thing. So this is going to be, I have to work with x11 because x10 has a value in it. X11, X11, and this is going to be X21, which is this mask value right here. So that's going to clear the upper 2 bytes. And what I'm going to do is shift this left. Shift left, logical, immediate, X11, X11, and I'm going to shift that 16 times to the left. At that point, I have my upper 2 bytes and lower 2 bytes in 2 different registers, which is X10 and X11. So what I'm going to do here is combine them. So there's different ways to combine these. I think I'm just going to add them. Add. And I have to store the result in X10, but it's adding the value in X10 to X11. So that's going to be a way of combining them. And I'll just put a nice label here for combine, and I'll put a done label in here for a return. Okay, so there's my entire solution. Now this was there's some issues with this solution. It looks good, and I know it's going to differ from the solution that's provided after this. So let's go ahead and look at that. The big thing here is that I didn't use an OR instruction. I used an add instruction, and so that works good. But there's something very interesting about this solution that I don't really. I mean, it's kind of a chunky solution because I wanted to show you masking on this thing. But as it turns out, you know what? I don't really need to mask these problems. It was just for example only. So what happens is, because I don't need to mask them, I can technically get rid of that, and that. Because what happens is, when I shift these instructions right or left, the hardware automatically fills in the empty bits with 0. So I technically didn't need to mask it. But like I said, it looked good at first. So anyway, that's the whole problem here.